Hello everybody, welcome to my new live stream where I'm learning C++. I hope the audio is clear. So today we'll be learning typecasting or type conversion in C++. So let us go right into the video. Let us start learning. I'm just checking the audio meanwhile. I hope it is good. I hope it is audible. All right. I think we can just continue. Okay. So type conversion in C++. Um, Type conversion is the process of converting a value from one data type to another compatible data type. It allows different types of data to work together in expressions, assignments, and function calls. Can occur automatically or manually. All right. If it is automatically, then it is implicit. Or if we do it manually, then it is explicit. Okay. Help secure compatibility between different data types. All right. Okay. So this is an example that they've given here. All right. Let me see how we can do this. So they have initialized an integer and a character. Okay. And then they have printed the character after manually converting it. Okay. So let's see how that's done. We have C out and then in the brackets, all right, they have passed the integer and then outside they have given the C, which is a character, and then they're adding some I and C, so I plus C over here because now this has been converted to integer, so now we can perform this operation. So I plus C, and then we are just printing the sum. All right. So I think that is so some of you might not understand why it is over here when you're printing sum. Why does it print 75 and 65? All right. So 65 actually is the ASCII value of A, right? So if you guys don't know, there are ASCII values, ASCII values. So if you refer this, so if you go through this, you will know there are ASCII values for every character. Over here, capital A starts from 65, small a starts from 97, and 0, right? So 0 is just 48. So that is the ASCII value over here, this chart. So here, as you can see, it starts from 65, goes up till 90, and then as you can see here, even for um, symbols, there is ASCII values. So, yep, and also the small letters. All right, let's just So that's what we need to know about ASCII values. Let's just try doing this by ourselves. All right. Okay, now I'm going to just create a new file here. Typecasting, typecasting.ctv. I'm just going to go with, okay, we just created a folder. Let me just create a new file. Type, typecasting, casting.cpp. All right. Okay, now we can just do this. Hash include IO stream. Basically, this whole program here. Okay, yeah. Let's just try this. Include. Is, eh, name. So let me just let me just write the main function as they've done here. Let me just do it. So they have initialized an integer int I equal to 10, and then car, I'm going to say car A equal to capital A, and or character C, so let's still see. So just done that. Now I need to typecast, right? So going to going to see out, not see out actually. Let me just um you have to see out the sum, right? Or let's just typecast and see out that as well first. So let's just see here when we typecast, I'm gonna say int, and then outside your C, and then you know is it handle or is it C? Let's say yeah, it's handle. So after typecasting, now let's go create another variable here, which is sum, and now we can perform this operation I plus C, and now also see out sum and L return return 0. All right, now we're good, I guess. Let me just check. Okay, let me just casting. All right. Please like the video, guys, if you're enjoying this kind of live stream and if you're finding it helpful. Also, if you haven't subscribed to the channel, please consider subscribing as well. Um, and let me know your questions or if you have something to discuss. Let me know in the live chat. I'll be checking them. So let me just run this. In the meantime, typecasting. All right. All right. So we got the output 65 and 75. So 65 is the ASCII value of A, which we printed here after a type conversion. And we also wanted to print the sum here of I plus C. So 65 plus 10, which is 75. So this is typecasting here, basic typecasting. So let me see if you have any questions. Please do ask if you have any. And let me know if you have joined. Just drop a hi in the chat. All right. And if you're learning C++, um, in if you're learning C++, in what stage are you? Like, are you learning loops or are you learning conditionals or are you learning typecasting right now? Like, at what stage are you in your journey? Let me know in the comments or in the live chat. So, for example, let's just change here. Um, for example, if I change this to from A to B, right? Now, what do you expect the output to be? Let me know if you know what the output would be. I just changed this to B. Now, what would the output be? If you know, please let me know in the chat. Let's see if we're all right. All right, so I think we can just check it now. Let's see. All right, now I've just converted it. This I've changed this from A to B. Let me see. Now the expected output should be here. It should print 65. Sorry, 65 is not what it should be. 65 was for A, so B it should be 66. And this value, the sum should be 76. Let's check if that's what we get. So the ASCII value of B is 66. Let's see. Yeah, so that's what we got, 66 and 76. All right. So let's see what is the next thing. So that's what is given here as an explanation. So there are two types of type conversion. It is implicit type conversion. It is performed automatically by the compiler whenever a value needs to be converted to convertible compatible type. So it occurs when performing operations on values of different data types, passing arguments to functions expecting a different type, assigning a value of one type to a variable of another compatible type. All right. So this is the hierarchy. Starts from bool, character, short, then int, long, 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 float, double, and long double. So that's how it goes. All right. There is another example given here. What happens here? All right, the same thing. And what have they done here? They have just directly converted it, directly done the operation. So here it is implicitly converted to integer. I hope you understood what is happening here. So basically, due to this hierarchy, right? So because of the hierarchy, integer is given like a higher hierarchy. So automatically when you do an integer added with a character, right? An integer is added with a character right here. So what happens is value of a is 97, small a, that is ASCII value. So you have 97 plus I, which is 10, so it is 107, all right. And x is implicitly converted to float, which means here you have float and float equal to I plus 1.0. So here, as you can see, here I don't think this is x, I think it is I. They have just made a mistake. So yeah, I is converted to float when we perform this operation. Here it is integer, but it's implicitly converted to float, and you just have these values over here. So I think we are outing. Yeah, all right. So the float value is printed in form of, yeah. So the float value is printed like this. So in this example, they are given the character A is automatically converted to ASCII value before being added to the integer variable. So that is what happens here. So, yep, that was that. I think it's clear there. That is implicit type conversion. What else do we have here? Let me also check the chat. I don't know how many of you are watching right now. Um, anyway, let's just keep going. All right. So this is the explicit typecasting order. So it is kind of the reverse decreasing order of size. So performed manually by the programmer to convert a value from one type to another. So this method here, there is a C style typecasting. It is inherited from C. All right. It's also called as forceful casting. Okay. So that is what we just did here, almost. Explicit conversion from double to integer. So as you can see here, let's try this actually. I guess we have a double initialized and then there is an explicit conversion here that is done. So while printing sum, so what happens here? So, all right. So I think how this is converted is this is a double, right? This has to be converted to integer. So how does that happen? I think it just takes the floor value here, which is just 1, and then 1 plus 1 just prints 2. All right. I guess that is how that happens. Okay. Yeah. So this is the risk that we have. Precision loss when converting floating point values to integers. So here, even when you convert double to an int, you have a precision problem, right? Because it is 1.2, actually it is 1.2 plus 1, but you need to get, you actually need to get 2.2, but you are getting only 2 because of this typecasting over here. So yeah, so that's what happened. Let's try and do this. Let's try what happens if we, let's try this. So I'm going to say integer. I'm going to say actually double here. Let's say double d equal to, I'm going to say maybe 12.5, 12.2, and then I'm going to see out, not see out here. Let's do the operation first. I'm going to say int sum equal to, here I'm going to typecast. Um, I'm going to typecast. So I'm going to say int int d plus 10. All right. So let's see what happens. I'm going to print sum here. So let's see what happens here. The output I expect is 12 plus 10. We should get 22. Let us see if we get 22. All right. Yeah, so we got 22. This is what we needed to get. All right. So that was, pretty much it. Yep, that was how you needed to do that. And cast operators. What is this cast operators? Let's see. Casting operators in C++. So do we have static cast and then you have a dynamic cast, right? So there are different types of casting. Reinterpret cast, right? Okay, let's not go into that for now. Like the video, guys, if you are finding this helpful, it helps to reach it to more people. All right, so let us see. So I think that's it of basic about basic typecasting. Let's see if we have something else we need to learn here. Okay, so here there is an explanation of, okay. So here, there you go. Here they have given static cost. Explicit conversion is equal to static cost operator because it is clear and type safe. All right. So let's see if there is an explanation for static cost. Where is it there? I don't see it. Um, Static cast, or do we have to check here? I think we'll just learn static cast. C++ typecasting operator used to perform explicit conversions between compatible types. Sort of commonly used for numeric conversions, user-defined conversions, inheritance-related class, and conversions involving void star, provides compile time, type checking, and is safer than C-style class. Suppose conversion, all right. Conversion between related types, user-defined types, and void. Cannot remove const qualifiers or perform low-level memory reinterpretation. All right, so what is going on here? I don't know why this keeps showing up. Let me just refresh. I have no idea. All right. You have questions? Any questions on typecasting? Please let me know. All right. So let's keep going. Um, so there is a float defined here, and then here there's an implicit typecasting. What is going on here? I don't understand. Why does it keep going? Okay. And then we have C out. Okay, A is printed, and then D is printed after the static typecasting. All right. So, okay. So static cast is just converting this float to end here. The fractional part is discarded during the conversion. Okay. All right. So it is done for type safety. So the syntax is the static cast here, static cast keyword, and then you have int, and then basically whatever you need to convert to, and then inside here the f which we defined here, right? So that is how you will static casting. So let's just try that. Um, Let me just try that. Okay, so static cast. So let me just change this to float. So float F, and I'm just going to change here. I'm just going to say static cast, and then you have um, I think it was like this, right? Or All right. You didn't need here. Okay. Didn't you didn't need the brackets here. You go inside and then say integer and then f, and then I'm going to do this. So let's try this one. Now the output should be 12 plus 10 again, which is going to print 22. So let's see, or let's just change this for, let's say 22 here. Now it should print 30, 32. Let's see. All right, it prints 32. So let us see what happens if I change this to 12.7 or maybe 12.5. Let's see what happens. Um, all right, still prints 32. Um, okay, so now I'll do 22.9. Sorry, not 12.9. So let's see what happens now. Again, prints 32. So yeah, so doesn't matter the decimal value. So decimal value just is ignored and only this part is after the decimal value, whatever is there, it is just ignored. Only the before the decimal point, whatever is there, only that is considered. So that is how the static cast works. All right. So let me just go to the next thing. What is done here? So uses of static cast. There is compile time safety. So because it rejects invalid conversions during compilation itself. So that is a good thing. So they have defined, as you can see, yeah. So there is a compile time safety here, shows an error. It does not allow conversion between unrelated pointer types, helping prevent unsafe type conversions. All right, makes sense. Here we are trying to convert, as you can see here, um, int star u and star and c. So here we are trying to convert this pointer here. So this is unrelated, right? So that's not allowed. Okay. So yep, that was pretty much about static cars. There are some limitations. You cannot safely cast between unrelated pointer types. Does not perform runtime type checking for downcasting. Cannot perform low-level memory reinterpretation. Reinterpret cast. All right. Anyway, that was um, all we needed to know, or like pretty much what we needed to know about typecasting. So let us see what we have next. I think next thing is, yeah, yeah, there are a lot of things to learn more. So let's see. I think we can do it later in the next live session. think we can end it for now. So let me know if you're watching after the live. Um, Let me know if you learned something new. And yeah, so like the video if you enjoyed watching, and subscribe to the channel. I'll be coming out with more new live sessions. Yeah, so until the next session, see you and thank you.